Thank you all for coming today. We're going to be talking about Smart on FHIR today and how to use Smart on FHIR for research applications. This is our agenda for today. I've got a couple of introductory slides. Then we're going to go through the workflow for using Smart App Launch, which is part of Smart on FHIR. We'll then talk a bit about the FHIR API, the US Core FHIR Implementation AIG, FHIR path, and then at the end, we'll have an opportunity to make a Smart on FHIR app yourself. I also have a demo version of that application that I'll walk through if anyone is interested in that. We'll take a short break too at about the 1 hour mark. And yeah, if anyone has questions, please feel free to ask in the chat or raise your hand or come off mute. All right, I'll start with the introduction. This is a quote from the Smart on FHIR specification. This explains what Smart on FHIR's goal is, and it is to create essentially an app store for applications that can interact with EHRs. The idea is that a developer should be able to write an application once and that it should be able to then run on any health system's EHR. Smart on FHIR provides a full stack of open specifications that enable this, and we'll talk more about what those specifications are as we get further into the workshop. SMART stands for Substitutable Medical Apps Reusable Technology, but really everyone just refers to this by SMART. It was created by the Smart Health IT group. And this is a link to their website here. There's some more information about what Smart Health IT does and the other standards they've been involved in if you're curious. Smart on FHIR is based on a number of open standards. I listed a few of them here. We'll get more into the details of that in a few slides. This technology is widely implemented. For example, it's used on all iPhones. If you've ever used the health app to connect to your patient portal and download your medical record information onto your phone, if you have an iPhone, it uses Smart on FHIR for this. One of the reasons that it's so widely implemented is that as part of the Office of the National Coordinator's EHR certification program, the Smart on FHIR standards are required in order to be certified. So this is a voluntary certification program that's run by ONC, and the rules that govern this are part of the 21st Century Cures Act. I've linked to two of the relevant rules here. The first talks about standardized APIs for patient and population services. The population part of this is FHIR bulk data, and we talked about that on the workshop that we did last week. Today, we'll be talking about the patient part of this, which is Smart on FHIR and the FHIR APIs and US Core. The second rule there talks about the specific APIs that include Smart Application Launch, and we'll be talking about that today. So this is a voluntary certification program, but CMS provides monetary incentives that mean that in practice, a lot of the production EHRs do conform to these standards. From a research perspective, Smart on FHIR lets you integrate an application with an EHR. So for example, if you have a new artificial intelligence-driven approach to clinical decision support, you could create a Smart on FHIR application and then use the Smart on FHIR APIs to link this into an EHR workflow. Smart on FHIR can also be used to add patient-generated data into an EHR workflow. And like I said on the first slide talking about Smart on FHIR, the goal of Smart on FHIR is to make it so that an app can be written once and then used across institutions and different EHR products. There may be some degree of institution-specific work that has to be done to enable this, but the basic APIs should be consistent across all EHRs that conform to these specifications. The last bullet point here is just another reference to the bulk data portion of Smart on FHIR. So this is what we talked about in the workshop last week. This is really for pulling one-off data pulls or regular background data pulls of large volumes of data. And what we're focusing on today is much more patient-centric and real time. So we're talking about applications where you would be trying to access patient data for a specific patient in real time. So there's no lag or background process there. You're pulling the data directly from the FHIR server when you need it. This is a list of the open standards that Smart on FHIR uses. So OAuth 2, OpenID Connect, and JSON, these are all common web standards that are used outside of the health domain. OAuth 2 and OpenID handle the authorization and authentication. JSON's the data format for the data that goes back and forth. The HL7 FHIR data model and API are used to describe the specific data and the API endpoints for requesting data from FHIR servers and sending it back if you're doing that. This bullet point here links directly to the Smart App Launch specification. So this is the specification that ties together OAuth 2 and OpenID for actually being able to do the authentication and authorization specifically for FHIR applications. And then CDS hooks are another technology. It's another HL7 standard that are for triggering based off of EHR actions. We'll talk a little bit more about that on the next slide. If you're not familiar with HL7, HL7 is the standards organization that deals with the creation and publication and balloting of a lot of different health-related standards in the US and internationally. And this includes obviously FHIR and CDS hooks, but there's other standards there as well that HL7 has in their standards process. I want to take a brief aside to talk about CDS hooks. We're not going to go into much detail on this, but I did want to mention this because it may be useful if you are working on developing a Smart on FHIR application. So like I said on the previous slide, CDS hooks is an HL7 standard, and it can trigger actions based off of what's going on in the EHR. So it can actually trigger a Smart on FHIR application if a specific event happens in the EHR. The example here is a patient view hook, and this can be triggered when the patient record is open. This could then call natural language processing software, or it could open up a Smart on FHIR application or recommend a Smart on FHIR application to the clinician who's using the EHR. So if you're wondering how you actually get people to use a Smart on FHIR application once it's been implemented and integrated with an EHR, this is one of the ways that that can happen. Going back to Smart on FHIR, there are a number of technical considerations that are common across Smart on FHIR applications. We'll go through several of them here. The first is that smart apps have multiple authorization patterns, and you need to decide which authorization pattern maps onto your use case. So the first of these is Smart App Launch. And there are two different options for Smart App Launch. One is an EHR launch, which is when a user launches a Smart on FHIR application from within an EHR, either by clicking a link or with a CDS hook. And this would typically be used by a clinician, like a physician or a nurse. The second option for Smart App Launch is a standalone launch. This is when a user launches the application directly. For example, in the iPhone Health app, when you connect that to your patient portal, that's a standalone launch. And this is typically for patient-facing applications where you're not going through an EHR. There's a third option here, which is a Smart Backend service. This is used by FHIR bulk data. We're not going to be talking about this today, but just so you're aware, there is an option to allow for authentication and authorization for a service that runs in the background that doesn't require any kind of user interaction to launch it. So that's what Smart Backend Service is for. From a security perspective, it is the best practice to use one of the existing reputable open source software libraries for handling the authentication and authorization pieces of Smart on FHIR. This can both save development time and avoid any kind of common security pitfall that you may run into if you don't have experience rolling your own OAuth software. This Smart Health IT website lists Smart on FHIR software libraries. We'll be using a JavaScript one today that's actually provided by the Smart Health IT folks, but there are other ones for other software libraries. From a privacy perspective, FHIR servers are likely going to be returning sensitive healthcare data. That won't be the case today because the test FHIR servers we're using use synthetic data, but if you're using obviously a production FHIR server, that will typically have identified data. So PHI rules are likely going to apply to this. You'll also have rules related to your IRB and privacy rules that you'll all need to figure out. From a design perspective, especially if you're creating an application that integrates into an EHR, we recommend taking a look at human-centered design if you are not familiar with this approach. There's a link here. This first link is to Wikipedia. The second link here is to this Fast Company article that talks a little bit more about human-centered design. And this is just a good approach to help to optimize the user experience because some of the user experience for applications involving clinical data can be pretty complicated. All right, we're going to get into the Smart App Launch workflow and walking through a demo of a sample app now. So the workflow that we're talking about is described in detail on the Smart App Launch specification page. I'll open this up here. It will let me. Here we go. So this this diagram here goes into detail in a generalized way, the workflow that we're going to be talking about today. So if you are working on a production implementation, definitely recommend taking a look at this diagram and this entire page here. For our purposes, we have a diagram that's specific to this workshop that's on the next slide. And we're going to be using this website, this launch.smarthealthit.org site to simulate an EHR launch today. So I'll go ahead and open this up too, just so you can see what this looks like. So basically, we'll be filling in the app launch URL here. So this would be that local host URL if you're running this yourself. And I'll talk more about that in a sec. So this will simulate a EHR launch. So that's basically if a user was clicking on a link to the Smart on FHIR application from inside an EHR. There are some differences with this test website versus the production implementation. So I'll try to call those out as we go here. This is that diagram that is specific to our workshop today. I'm going to show a different version of this just to make it a little bit easier to read. So like I said, we're going to start off with this launch.smarthealthit.org website. I'm going to call this the test launcher going forward here. So the test launcher is going to trigger a launch. And what that means is that it will hit this localhost URL with launch.html. And it will provide it a couple parameters, and we'll talk about those in a minute. When this page loads, some JavaScript is going to do an authorization request. This will send us back to the test launcher. And the test launcher is going to give us a dummy workflow for a provider login and patient selection. So this is one of those things that's different from a production implementation. In production, if a user clicks on a smart app launch link, the system's already going to know the context. It's going to know that a user has been logged in and which patient is selected. But for testing, we don't know that. So we have this dummy workflow where you basically see a pretend login screen, a list of synthetic patients, you select a patient, and then that provides that context that's necessary to continue. The next step is to grant authorization. So we'll then be redirected back to localhost. This time we'll be hitting index.html. And once that is granted, index.html page, again with JavaScript, is going to request an access token. That token is going to be what we use to authenticate for all the FHIR requests that we're going to be making. We'll get that access token back from the test launcher, and then we'll be able to actually hit the FHIR server here. So we'll be able to request a patient. We'll get JSON in response to that. We'll then request medications in our sample app, or this medication request instances, and then we'll get those back again as JSON format. So this is the flow we're going to be going through today. I'm going to go through each of these steps in detail and actually look at the code that generates this. All right, let me get back to the slides here. Okay, so the basic sample app that we're looking at is in this repository right here. This is what I have open in my editor here. There's a detailed explanation of what I'm talking about today on our documentation website. So if you open this up and scroll through it, you'll see a lot of what we've already been talking about today. And you'll actually see the code that we're using and explanations of the code. So if you are interested in looking at this more on your own, this is a good resource for that. For anyone who's following along with localhost, this is now where you're going to want to make sure your localhost is running. For anyone who's not running on localhost, you can actually use this URL here, and I'll show what that looks like. And then we're going to go and before we get into the details of this workflow, I'm actually just going to show you what it looks like here. So I'm going to use the hosted version. And remember, we're going to hit launch HTML. So when I click this launch button, this is going to kick off a request that goes to launch.html. It's going to immediately redirect me back to the test launcher here. And then this is that dummy workflow for logging in. So I'll go ahead and click login. I'll select a patient here. That automatically redirected me to index.html. You can see up here. And that went ahead and made those requests to get the patient, FHIR, and the medications. These are medication request instances. So that went pretty quick. Don't worry, we're going to go through everything in detail here. So I'll go back to the slides. If you're looking at this in the future and for some reason something is down, you can play this video. It goes through exactly what I just did. So the structure of this application, there's two pages here. Like I said, launch.html and index.html. The launch page just handles the launch, and we'll look at the code for that in a second here. Index.html is the application. So if you were writing a single page app, it could be all on index.html, or it could, if you have a more complicated app, you can structure it differently here. The contents of all these files, again, are on this GitHub repository. If you've cloned the repository, you've got this already. So I'm going to go through each of the steps in detail here. I'm going to repeat myself just a little bit, just for context. So the first step is going to the test launcher, entering that URL, and then clicking the launch button. This will redirect to the page that we specify. It's going to send a couple of parameters. It's going to send the ISS, which identifies the EHR's endpoint for the application. It's also going to send a launch parameter. This is an opaque identifier that provides the context that's specific to the app launch. This is required for security purposes, and the JavaScript library that we're using automatically passes this back to the EHR in the next step here. So in the second step, we're going to look a little bit at some code, and we'll see the JavaScript library that we're using. So this is that Smart on FHIR JavaScript library is provided by the Smart Health IT folks. There are other libraries for other languages, but this is what we're going to be using today. And what this library does is it handles the OAuth 2 workflow for us. It also handles making authenticated requests to the FHIR server. So actually, before I get into step 2, I'll just open up the launch page just quickly here so you can see what it looks like. So you can see that we're using that FHIR client that I just mentioned here. We're calling this FHIR.OAuth2.authorize method. We're passing in a client ID. This can be anything for this purpose, but in a production setting, this would be a client ID that you've pre-registered. We're going to set some scopes. Again, we can be pretty loose with this for our testing purposes, but in production, you'd want to limit this to just the specific scopes that you need to accomplish whatever your use case is. And then we're going to set a redirect here, and this should actually be index.html. My local copy isn't up to date here. So what this is telling us is that, this is telling the test launcher that after it does the OAuth 2 authorization authentication part, then it's going to send the user to this page here. And the localhost 3000 prefix, if that's what you're using, automatically gets prepended to this. So we can just put in the path relative to that. Okay. So now we're, let's see here. All right, so for step 3, we've done the launch. We've been redirected back to the test launcher. Now the EHR is going to allow you to select a provider and a patient. So that's that dummy workflow I mentioned previously. Again, this is different from the real world. An EHR would pull this from context or show a screen asking for a patient to give permission for access. After we authorize and authenticate, we get redirected to index.html or whatever page we specify. This is what that page looks like before it actually makes the FHIR requests. And then as soon as it loads, it's going to call this function here, which makes sure that the OAuth authentication is in place. Once that's done, it can call this method here to get the patient information. This comes back in FHIR format in JSON. And for the purposes of the sample application, all we're doing here is we're storing the FHIR response in this PT variable. So this library takes care of translating the JSON into a native JavaScript object. So that's what's in this PT variable. And then what we're going to do here, just for demonstration purposes, is we're actually going to convert this right back into JSON, and we're going to stick it in this box right here. So that's what's going on there. This is the JSON that's come back from the FHIR server. We have a little bit of error handling here as well. The next thing we're going to do on index.html is request the medication request instances. So here we're going to use a different method. We're going to use client.request, which lets us make an arbitrary FHIR API request to the server. We'll be talking more about the FHIR API on subsequent slides, but for now, I'll just talk really briefly about this. We're basically saying, hey, give us the medication request for a specific patient. This is the patient we get from this, from the client.patient.id. And then down here, it's grayed out, but we have a little bit more error handling, and we do exactly the same thing. We shove this back into JSON and stick it in this box here. So that's where these medications are coming from. It's a bunch of medication request instances. All right, I'll pause here for a moment before we get into the FHIR API and see if anyone has any questions. Okay, I'll talk a little bit about the FHIR API now. So FHIR has a RESTful API. It has the standard format that you're familiar with if you've looked at RESTful APIs before. You have an HTTP verb. For our purposes today, we're always going to be using the GET verb. We have a base, which is the URL where the FHIR server endpoint lives. We have a specific FHIR resource, and then we have some optional parameters and values. This link here goes to the FHIR specification. This is for R4 because we're using the FHIR R4 release in our examples today. FHIR R5 is actually out now. So if you go here, you'll see this angry warning at the top, and you can see that FHIR R5 is an option that you can jump onto. If you are writing a Smart on FHIR application, it's a good idea to lost my slide there. It's a good idea to take a look at this page and familiarize yourself. There are a lot of FHIR specific API endpoints that are mapped onto the RESTful interface. This is the page that describes those. Today, we're going to be focused on the read and the search operations. Before I get into some examples of those, I want to talk a little bit about using synthetic data as a way to test your code. So what we've talked about so far has been a fair bit of work to do the authentication and authorization dance to get access to a real-world FHIR server. If you're just trying to test something out or see how something works, there's a lot of overhead there. And one way around that is to have an open FHIR endpoint and use synthetic data. We've set this up using something called Cynthia and something called the Logica Sandbox. Cynthia is a tool for generating synthetic data. On our documentation website, there's this whole page talking about an overview of Cynthia. It actually talks about how to run and customize Cynthia and how to run a FHIR test server yourself. So if you're interested in doing this, these are great resources to get you started there. For today, we've already loaded synthetic data into a Logica Sandbox. This is a service that's provided by Logica Health that allows you to have both authenticated and open FHIR API endpoints. And it's a good tool to use in addition to this test launcher from Smart Health IT. You can do similar things with the Logica Sandbox. In addition, you can also have an open FHIR server and load it in with custom data. So for this section using the FHIR API, rather than using the test launcher that we were using before, we're actually going to switch over and use this Logica open endpoint just because it simplifies everything a little bit. So you can download Cynthia data as a batch from this website here. This isn't customized or anything. It's just standard Cynthia data. And then you can pretty easily load it into Logica. And what that will allow you to do is have a very simple set of JavaScript or another programming language that will let you hit this URL here and get information back from the FHIR API. So we'll be using this just as a way to test out some FHIR API requests. So the first thing I'll talk about is just getting a specific patient resource. FHIR breaks up information into chunks of data that are called resources, and then these are connected together with references. Our documentation website has a lot of information about key FHIR resources and how resources work and are structured. So if you're interested in learning more, that's a good place to start. Another good place to go is this list of all the resources. This link is to FHIR R5. We can go back to FHIR R4 if we want to. Maybe if it will let me. All right, here's FHIR R4. So in R4, these are the different resources that we have. There's a lot of them. There's more than 100. I'll talk a little bit more later on in the workshop about how to figure out which FHIR resources are relevant for what you're doing. But if you need the list of all of them, this is where you would go to get that. So if we want to get a specific patient resource instance based off of an ID, we can use this format to get that. So the first thing I'm going to do, I'm actually not going to put an ID on here. I'm going to go ahead and run this, and this will actually give me all the patients that are on this server. And then this will allow me to get the ID of a patient. And we can see here there's a patient with ID of 1. So I should be able to add a 1 here and then save this. This will refresh. And then I will have just a patient. So the resource type I'm getting back is patient. You can see this is the request I'm making here. And then this is the standard JSON that you would expect for an instance of the patient resource. If you want to figure out what's in here or what these different data elements mean, the best way to do this is to actually go and open up the resource in the FHIR documentation. So for example, if we want to look at the patient's name here, we can see this data element has a human name type. We look at our example. Let's see here, we should have a name in here. Yeah, so here's the name. And then we can see here that the use is official. We've got a family name, a given name, and a prefix. If you're not familiar with what use is, you can actually click into human name. And then you can see use here is bound to a specific value set. And we can open up that value set. And we can see that official is the formal name as registered in an official government registry, but may not be commonly used. This is synonymous with a legal name. So that's what is possible by taking a look at the FHIR specification for a given resource. We'll move on now to medication requests. So I'll open up the documentation for this. Medication request is an order or request for the supply of medication and the administration instructions. There are a number of medication-related resources in FHIR. It can be a little bit confusing which one to use. Our synthetic data has medication request, so we're not going to worry about that today. We're just going to use medication request and pretend that that's the place where all the medication information is. But depending on how your EHR works, that may not actually be the case. So if we want to get the medication request for a specific patient, we know that that is connected to patient within this subject data element. So if we go back here and look at the specification, we can see subject is a reference to either a patient or a group. And it is defined as the individual or group for whom the medication has been requested. So if we wanted to get medication requests for a specific patient, we can do that with this right here. So I'll go ahead and change this. And we'll say subject equals 1. And we can see here that this is loaded. If we look at the reference, we can see it references patient 1, which is what we expect. And then this is we can see we have a RX norm code here for specific medication. So the results to a search, this is a search rather than a read, they're returned as a bundle rather than just the instance of the FHIR resource. So if we look here, we can see that the resource type is a bundle. If we look at the documentation for bundle, it's another FHIR resource, and we can see that there is an entry element. The entry element contains all the different entries in the bundle, and the resource element inside of entry is where the resource actually lives. And we can see that's what's going on right here. So you see we have entry as a top level element. We then have resource as a sub element. And then every entry is going to have a resource. And in that resource, this is the actual instance of the medication request resource that we want. So if this patient had more than one medication request associated with them, this object right here would just be repeated multiple times for each of those instances. So the FHIR API also allows for some more advanced searches. We'll talk about 2 different things here, chaining and reverse chaining, and then some of the Boolean logic that's possible for filtering. And then at the very end, I'll show the link to the documentation on searching. So a medication request has a reference back to a patient. If we want to retrieve instances of medication requests, if we know a specific patient's ID, that's easy. We've seen how to do that already. But what if we only know the patient's last name? The reference has the patient ID in it, right? We can see that reference right here. It has the patient ID. It doesn't have anything related to the patient's name. If we wanted to do this, so let's say we want a patient that has the string Peter appearing in their name somewhere. We could do this in two queries. First, we could just get all the patients who have Peter appearing in their name. And then we can make a second request and get all the medication requests for patients with that with those IDs. The FHIR API allows you to do this with just one query. And this is really useful if you are writing an actual application here, because you can really simplify the code that you need to write and just directly get the information that you need. So with chaining, we can just simply go into subject and say subject.name equals Peter. And this is equivalent to making these two separate queries. So I'll go ahead and do this here. And I'm just going to put one letter in here. And what this will do is it will get all the patients where the letter A appears somewhere in their name. And we can see here we have another bundle. And we're going to have a bunch of patients or a bunch of medication requests here for patients that have an A somewhere in their name. If we want to actually prove that the patient has an A in their name, we can just change this back to patient and look specifically at that one patient. And let's see, hopefully there's an A in this person's name. I can find their name here. Here we go. Ah, yes, Aaron. What a great example for a name with an A. All right, so that works. I mentioned before that medication request.subject is a reference to either a patient or a group. So a better approach to this is to actually specify with this colon syntax here that we want the subject to be patient.name rather than group.name. So this this FHIR API request will only return medication requests where the subject refers to a patient and that patient has the word Peter somewhere in their name. Another operation that you can do with the FHIR API is reverse chaining. So this allows you to answer a question like, what patients are diagnosed with a given condition? So if we can open up condition here, we'll see there is also a subject element. It is also a reference to patient or group, and it's the description is who has the condition. So that's the thing that we care about here. The problem is that the reference is on the condition side, it's not on the patient side. So if we want patients that are diagnosed with a condition, we could do the naive approach, which is to get all the conditions and then look at all those references and then just load all those references for all those patients. That's pretty laborious. So FHIR provides reverse chaining as a way to get around that. The way this is done is with this has parameter, colon separate fields, and then the subparameters are the resource type to search for references back from, the field on the resource that you want to look at, in this case, subject, for doing that link, and then the field that you want to filter on, in this case, it's code. So here we want the patients who have a condition, specifically this condition here, and we're going to do that link up via this subject element. And I'll go ahead and copy and paste this over. and run this. And some of these can take a second to run because the server is doing some more work here. But we'll see we do get back a bunch of different patients. And then if we wanted to go in and look at the conditions for this patient, we would see this condition code here. And that condition code is, it's a SNOMED code. If you're curious what disease that was. All right. So as I promised, I would show the link to the chaining documentation. So all right, let me open this up in a new window here. So first, I'll actually scroll up to the top of this page. You see it's a very long page. This is the search page in the FHIR RESTful API documentation. There's lots of features here. Well, let me get back down to chaining. Yeah, here we go. So this talks about chaining and reverse chaining. If you are working on a Smart on FHIR application, you're using the FHIR API a lot, I recommend reading through this whole page. It provides a lot of really useful information. And there's lots of features that we don't have time to go into today, but may be useful depending on what your specific use case is. The last thing I want to mention for today, just to make you aware that this is a feature that's available, is searching for multiple values. This is another feature of that search API. It allows you to do logical operations like a logical AND or a logical OR. For example, if we wanted to get a patient who has John in their given name and Smith in their family name, we can do that with this pretty logical syntax here. And this operates as an AND, so it will only return patients who have both of these criteria that are true. If we wanted to find John Smith or Jenny Smith, you can use this comma syntax for a logical OR. There's lots more about this in the spec. You can go to this section here on combining that will give you much more information if you are interested. All right, before I get into US Core, I'll pause again to see if there's any questions. Okay, I'll spend just a couple minutes talking about US Core. So US Core is the FHIR implementation of US CDI. US CDI stands for US Core Data for Interoperability. US CDI is a set of common data elements. Let me open it up here. Common data elements for health data interoperability in the United States. It specifies the data elements, but it doesn't specify the data model. US Core is the FHIR implementation, so it actually takes those data elements and then uses FHIR to specify a data model. Conformance to US Core and US CDI is part of those ONC EHR certification program rules. So like Smart on FHIR, adoption is pretty widespread in production EHRs. And this is important because if you are using a Smart on FHIR application, you're trying to get access to FHIR resources for research purposes, the availability of specific data elements may depend on your institution's EHR vendor and their implementation of FHIR. But if your data elements happen to be part of US Core and US CDI, then you can be pretty confident that they're going to be represented in a standardized way. If you're trying to then have an application that works across EHR installations and EHR vendors, using data from US Core means there's going to be less customization that has to be done for those different FHIR servers. This is a link to the US Core specification. This is a FHIR implementation guide. Implementation guides are the way that FHIR is customized and extended for specific use cases. One of the interesting pages as part of this implementation guide are the list of profiles and extensions. So I mentioned a little while ago that I was going to note how you might be able to narrow down which of the hundreds of FHIR resources are relevant to your research use case. This list in US Core is much smaller. So these are different FHIR resources. And then this link here goes to the US Core profile of that resource. So this is a customization of the allergy intolerance, allergy intolerance resource that is specific for this US Core use case. So there's a much smaller list of profiles here and resources here. So if your data fits into one of these resources, then it is likely that it will be available on a large number of production FHIR servers. If it's not available, then it really just depends on the specifics of the data. Sorry, if it's not available in US Core, it really just depends on the specifics of the data that you're talking about, whether it's going to be available or not. Observation is one of the most commonly used FHIR resources. US Core has a number of different profiles on observation for different use cases. So we can see we have BMI, body height, body weight, body temperature. We'll just click into one of these and take a look at it here. So this table looks similar to looking at a FHIR resource. And in fact, if we click on observation here, we'll see that familiar. We have to go under content. We'll see that. Is this not working? I had it. Okay. So this is actually kind of interesting. Let me come back to this in a minute. We'll look at this profile instead, and then we'll come back to that. Okay, so this differential table, interesting. These links aren't working for me. Okay. Anyway, this differential table shows what the profile does on top of observation. So we can see that it's adding this must support flag for a number of different data elements here. It's also making some data elements required that were not required in the base FHIR resource. Must support is a flag that indicates that a data element is supposed to be supported by implementers. From the perspective of a FHIR server that's providing FHIR data, this typically means that if the data element is available, it should be provided as part of the instances of the FHIR resources that the server returns. For a application that's reading FHIR resources, must support is context dependent on what that application is doing, or the implementation guide may specify some specific rules for that particular kind of actor. All right, let me get back to one of these other profiles here. So we're going to be looking at condition and medication request and patient today. I'll go into the patient profile here, just flag a couple of things. So I mentioned that profiles are the way that FHIR resources can be extended or constrained for a specific use case. Constraints are things like making a data element required. So you can see that this profile here, it adds this minimum cardinality of 1, which means that identifier must be included in FHIR resource instances that conform to this profile. So there's a number of constraints here that have been added like that. There also are a number of extensions. Race and ethnicity are very common data elements that appear in US healthcare data, but are not necessarily included in data in other jurisdictions. Because US Core is specific to the US context, it adds these extensions for race and ethnicity. So even though race and ethnicity are not part of the core FHIR patient resource, for implementations that conform to this US Core implementation guide, race and ethnicity will still be represented in a consistent way. So this means that if you're writing a Smart on FHIR application that uses race and ethnicity, this is how you will know how these data elements will be represented in the FHIR data that you're going to receive. So by looking at this implementation guide and then actually jumping into this extension and seeing exactly what's going on with race here. And in this case, it uses a OMB category for race. You can jump into the value set binding, and you can see what these different codes are and what they mean. All right, let me get back to the patient resource here, the patient profile. So profiles have a parent type. In this case, the parent of this profile is the FHIR patient resource. And if we click on this, I have to do a new window here, I think. This will actually take us back to the FHIR specification. But it's possible for profiles to have another profile as a parent. And that's what we actually saw when I got tripped up with observation a minute ago. So because observation has this hierarchy here in US core, so if we open up, let's just pick height, for example, its parent is actually this US core vital signs profile. And what this allows is to have, for all vital signs, there's going to be some consistent data elements. And then there's going to be some specific things for a specific kind of vital sign. So in this case, we're fixing the code for body height to this particular loink. But if we jump up to the vital signs profile, we can see that it doesn't specify a specific code. So if you're looking at a implementation guide, you can follow these links here or look at the text up here and see what a given profile is derived from. And you can follow that hierarchy. It always goes back to a base FHIR resource. If you're interested in learning more about how to read FHIR implementation guides, our documentation website has a page about this. It actually links out to another website that has a lot of information about how to generally read a FHIR implementation guide, and then additional information about creating implementation guides, including some hands-on exercises. We're not going to be talking more about this today. But if you're interested, definitely recommend checking this out. We also include a little bit of information that's specific for a research context about what you should be thinking about when reading a FHIR implementation guide from a research perspective. All right, the next thing I'm going to talk about is something called FHIR Path. This is another HL7 standard. It's a tool for navigating and extracting from FHIR resource instances or FHIR resources. And you can see here, this is a link to, if it will open, to FHIR Path. It's like I said, an HL7 specification. It's a pretty long page, as you can see here. We're not going to be using most of what FHIR Path does. We're really going to be focusing on a few of the features that make it easier to extract data. Because FHIR does have a deeply nested hierarchical structure, it's useful to have something like this rather than manually having to traverse the data structure in your programming language's native approach for dealing with hierarchical data. So there's a JavaScript implementation of this that we're going to be using. This actually comes from HL7. And there's actually a sandbox that they provide. So I'll go ahead and open this up here. This is, again, one of those online tools that's super useful, but also you shouldn't be putting any kind of identified patient data in here. It's really only appropriate for synthetic data. So this is the syntax for a FHIR path. We're going to be looking a little bit on this in the next slide here. And basically what's happening is you provide a sample FHIR resource instance, and then a FHIR path, and it spits out the thing that you target with the FHIR path. So just a couple of quick examples here. If we want to grab the gender element, we can just do patient.name.gender. I don't think this sample patient has, they have gender for a contact, but I actually don't think the sample patient has a gender. So let's go and grab a patient from our synthetic data here and paste that in. I need to be a little bit more careful with what I'm selecting here, I think. Try that again. Oh, this is what's going on here. There we go. And that was my bug. There we go. Okay, so patient.gender data element is male. If you want to get a patient's legal name, you can use this where feature. So we can say patient.name where the use data element is official, and then get the family name from that. So I'll paste this in here and then show what that looks like. So we see we're pulling here a family name. And what's going on here is with this where feature, use is the use data element that's inside of patient.name. So if we scroll down here to name, we can see there's a use element, and then official is a potential value for that. If we remember from what we saw in that value set, you could also have, you could have like a maiden name or like a common name rather than an official name. So if you're trying to get a patient's name, they have multiple names, this is a way that you can filter down to make sure you have exactly the one that you want. If we want to get a patient's MRN, that's also possible here. It's a little bit more complicated, so I'll paste this in here and then talk through it. And there's a slight difference in the code system between my example patient and the example that I'm using for this. So let's see here. Yeah, so I need to switch this and then it will work. All right, and then you can see we're getting the medical record value. So let me explain what's going on here. So we're starting with patient.identifier. And then we're saying we want the identifier where the type is medical record number. This is the code from this particular code system that is used for medical record number. However, you could have a different code system here. So you don't want to just say type.coding.code is medical is MR, because that might mean something in a different code system. So to be as robust as possible, we're going to use we're going to actually specify the code system as well. However, you saw that there was a slight difference in the way in this code system canonical URI that identifies the code system between the two different examples, the example that comes up when you just load this page and the example that I pasted in a minute ago. So that's just something to watch out for. That's the kind of thing that has to be potentially dealt with as something that could differ between systems, between different FHIR servers. So when we get into the example application, I'll show how FHIR path is used in practice and how it can simplify code a little bit. If you want to do this on your own, you don't want to be spoiled by the demo, I'll give you a chance to basically turn your audio off before I start getting into the run through of the example. For everyone else, if you want to stay on and listen to me walk through the example or try running it yourself, we can do that. If you have questions, if you're trying to work on it yourself, we can try to help you out. So the prompt for this exercise is to create a decision support tool to identify medication interactions for a given patient. We're going to make a couple of assumptions here. We're going to assume this is going to be launched via EHR launch, so clicking a button inside an EHR. This could also be embedded inside an iframe directly in an EHR inline. It's the same mechanism. We're not going to be doing that here, but you certainly could. We're going to use FHIR to retrieve the medication request instances for a given patient. We're assuming that medication request essentially means lowercase medication for the purposes of this, although there are several different medication related FHIR resources. You want to make sure you pick the right one for your given EHR and implementation. We'll be using a different API that's not a FHIR API. It's not from the FHIR test server, called RxNorm, for checking for drug-drug interactions. And then we're going to display a patient's conditions, medications, and flag any drug-drug interactions. So this link here goes to the API documentation. I'll stick that link in the chat here. I need to open a new window. Okay. So this API comes from the National Library of Medicine. And it's a pretty straightforward, just a standard REST API, nothing specific to FHIR here. You can provide a list of RxNorm IDs and then specify a data source if you want to. We're just going to be doing the RxNorm IDs. So this is an example of what that looks like. So if we run this particular GET request here, we'll get a patient back. That patient will have these 4 RxNorm codes for medications. So then we can plug these into that API I just showed you, and we'll get a JSON response. This is what that JSON looks like. And we'll basically have an array of interactions here with some information about those interactions. So we can see that this ID and this ID interact, and we have a description of what's going on with that interaction there. So this is the API we'll be using. If you're going to implement this yourself, you want to take a look at this documentation. It's pretty short here. You can just sort of read through what's going on. And we can get this back. You can see that there's XML and JSON options here. We're using the JSON option. All right. So here's a mock-up of what we're thinking about to try to make this a little bit more tangible. So we're going to have a web page here. We're going to load in a specific patient, show their MRN up top there, just for clarity about which patient we're looking at. We're going to have a list of conditions right here, a list of medications, and then we're going to flag any drug-drug interactions. So remember, this is going to be coming from a condition resource. This is medication request resources, and the source of this is the RxNorm API. And the patient name and ID come from a patient resource. If you're interested in extending this beyond that basic example, some ideas for that are enhanced patient information, like adding the date of birth or allergies, that kind of stuff that would typically show up in an EHR. You could show the providers who requested a given medication if there's an interaction. You could group medications and drug-drug interactions together by encounter. These are just some ideas if you want to go beyond the basic prompt here on your own. So I will now go through the example application. So in a sec, I'll give anyone who wants to a chance to mute so they don't spoil themselves. Just for a little bit of wrap up here, so there's some additional resources. I've linked to our website a bunch of different times here already. I'll stick this link in the chat again. If you want to get more information about this, a lot of the information we've talked about today is available in a written format on our website. Docs.smarthealthit.org has a bunch of relevant information, tutorials, test environment, vendor sandboxes, sample apps. There's the official Smart App Launch Implementation Guide. If you have questions after the workshop ends, if you're working on your own implementation, chat.phir.org is a great way to get information or ask questions and get input from the FHIR community. It's very active there. There's a specific smart stream, which is essentially the same as like a channel on Teams or on Slack, where you can ask questions specifically about Smart on FHIR. You have to sign up for this, but it's a free account. It runs something called Zulip, which is an open source version of something like Slack or Teams chat. And it's a great place to be if you're trying to do your own implementation here. There's also a community mailing list for Smart on FHIR. I'll stick the link to that in the chat as well. So these are all good resources for after this after this workshop if you still have questions. And then the last thing I'll do before I get into the app is one more plug to fill out the survey. So I'll paste the survey link into the chat again. So if you haven't opened this up and started filling it out already, please fill it out, and please just try to finish it before you drop off the call here, just so you don't forget, because we'll use this information to make the future workshops and other things that we do better. Okay, I'm going to clean up my windows here a little bit, or my tabs, and then I'll get into going through this sample application. So this is the point where if you are not interested in going through a JavaScript application in detail with me, you can mute now or drop off now, and just come back if you have questions. We'll be hanging out here until 4 o'clock, or until everyone has decided that they are ready to leave the workshop. So if you do want to work on this yourself, or you just want to look through the documentation and be able to ask questions, we'll be hanging out here to answer them. Okay, I'm going to start going through this sample application now. So I'll spend a few minutes just talking through this, and I'll actually show how this works. So we're going to be using a number of different JavaScript libraries here. We're going to be using a few general purpose libraries. So Tailwind is a CSS library for styling. We're going to be using Alpine, which is a JavaScript library for creating, for essentially rapid prototyping or creating simple JavaScript applications. You can use it for more complicated things too. We're going to be using FHIR. We're actually also going to be using this library for making HTTP requests with JavaScript. Just makes it a little bit easier. So the way that Alpine works is you can define the essentially instance variables that you want to have accessible to the HTML on your web page. And then you define an initializer in this init method here. This will call the connect to FHIR method. And the connect to FHIR method is where all our business logic lives. So this is equivalent to this really simple index.html page we were looking at earlier. It's just more complex, though, the logic that's going on here. So I'll walk through this line by line, and then we'll go ahead and run this and sort of see how it works. So in this connect to FHIR function here, we're again going to use FHIR.oauth2.ready. So if you recall, this method will trigger this promise once the OAuth authentication authorization dance has been completed with the test launch server. We're going to store the client in this client variable here. We'll use client.patient.read to get the FHIR instance of patient for the particular patient that's in been selected through the EHR. We'll go ahead and pull out the patient's name. Here we're just doing this with vanilla JavaScript. We're just assuming that the patient only has one name, or that we're just going to trust whatever is in the first position in this name array. We'll assume the patient has both a given and a family name. This may not be true all the time, but in our synthetic data, it is true. We'll concatenate these together. That gives us the patient name. For the next thing, we want to get the patient's MRN. We're going to use that FHIR path I was showing earlier for this. So we're going to look in patient.identifier. We're going to use this this where function to get only the value where the code system is this code system here, and the code is MR for medical record, and then we're going to pull the value out here. We're going to use the FHIR path library, so that comes from this right here. We'll use FHIR path and run this method to actually evaluate the FHIR path on the patient object. So that's this right here. We're going to pass in the path, and then we're going to say it's FHIR R4. That gives us the two pieces of patient information we're pulling in. So if you recall from our mockup, we're interested in pulling in the patient's name and their MRN. So we've got those two variables here. And like I was saying before, these end up in these instance variables up here that are available to the HTML, which we'll look at in a sec down below. So then we're going to do two very similar different operations here to get the conditions and the medications. So this is the FHIR search API request to get all the conditions for a given patient. We get the patient ID from client.patient. And then again, we're going to use a FHIR path. Remember that search APIs return bundles, so we're going to use bundle to entry. We're going to make sure we're getting conditions. That should always be the case because this API call should only return conditions. So this is just extra robustness to make sure we don't run into weird errors here. And then we're going to pull out resource.code.coding. And we'll set that to the conditions, this conditions instance variable. So resource.code.coding is going to actually, this is not just a string or an integer. This is actually an object. And if we look down below at the HTML, we can see how that object is used. So we'll come back to this in a minute once we're looking at the HTML. We're going to do exactly the same thing for medication request. In this case, we can use vanilla JavaScript. We don't have to use FHIR path. And then we're going to call load drug interactions once we get the medications. The load drug interactions function, this is going to call out to that RxNorm API. So basically, we're going to take the medications, we're going to map them and pull the code out. We're going to join those codes with a plus symbol. That's what the API documentation told us to do. Then we're going to stick that in here in this parameter. And then we're going to set an instance variable with the interactions, again, just using vanilla JavaScript to pull out the information that we want here. So that's going to create all of these instance variables that we need: the patient name, the patient MRN, and then array of conditions, an array of medications, and an array of interactions. So in the HTML here, this X data, this is Alpine specific. So you'll see this X dash syntax a few times here. This is how Alpine does the magic to associate specific HTML elements with the instance variables we set up above. The classes here, this is Tailwind. So this is how we set the background color in this case, and do the layout of the HTML elements on the page. So you'll see here, we're going to say patient, and then we're going to set the text to that patient name instance variable. Same thing with MRN. For the conditions, we're going to iterate through all the conditions in that conditions instance variable. We're going to have a link where the text for the link is set to the display text for the condition. And then the href is set to this URL, which will actually go to the SNOMED code in question. And then we're going to do exactly the same thing for medications, and then the same thing for the interactions here. So now that we have all this in place, we can actually go and run this and see how it works. So what I'm going to do is go to my launch.html page here, and I'm going to change this and change it to example app.html. And then I can go ahead and get my localhost URL here for this launch page. Remember, this doesn't show anything because launch.html doesn't have anything besides this little JavaScript here. But then what I can do is I can go to launch.smarthealthit.org. I can paste in my localhost URL and click launch. It's going to walk me through this dummy workflow again. I'll go ahead and select a patient here. And you can see that this automatically loads and populates everything in. So if we look at the inspector, and we'll go ahead and clear this out and then just reload this page here. And we can see what's going on here. So you see, we are hitting, let me see here. Okay, so we're hitting this URL here. And this is, it might be a little bit hard to see. I don't know if I can zoom. Oh yeah, I can zoom this in. Great. Okay, let me zoom this in. So we're hitting the this API endpoint for patient. We're getting this specific patient. Notice that this is not the same as the URN. This here is the FHIR ID for the patient. The MRN is a separate identifier that's part of the FHIR resource, but it's not actually the same as the ID. But we can get the response that we're getting for this is the patient, the instance of patient, and then if we scroll down here, and eventually we will find identifiers. Here's our MRN, and you can see this right here maps up to the MRN we're showing at the top here. So that's what's going on there. We're also hitting condition and medication request. So those are loading in this list of conditions, this list of medications, and then you can see here that we're hitting the RX norm API to get the drug-drug interactions. And the drug-drug interactions, the way we're displaying this isn't super user-friendly, right? They're not actually linked up to the specific medications, which would be nice here. It'd be nice to see some indication of which of these RX norm codes. Maybe if you mouse over this, it should highlight 2 medications over here or something. We didn't implement that for the sample app. If you click on any of these conditions, it will open up a new window. Conditions that we're using are SNOMED codes. So this will open up this nice SNOMED concept browser and allow you to see exactly what this particular code refers to, which might be nice. So if that display text there isn't sufficient, you can jump in and see exactly what's going on there. We did the same thing with medications. You can click on one of these medications and actually jump into the RX norm Explorer, and you can see all these different details about this particular medication. And then let's see here. So I'll go ahead and launch this for a different patient just so you can see what that looks like. So I'll pick a patient, a different patient here, and you can see if we compare, different data gets pulled in here, depending on which patient we select. So you can imagine this being embedded in a EHR potentially, maybe not show, maybe some of this data is duplicative, but the drug interactions potentially could be useful.